All right. I decided I was going to go ahead and knock out a solution set of this AP free response set of questions. I don't have the answer key up yet, so I'll have to pull that up in a minute. But I'm going to go ahead and get started. I am going to turn off the um, video there in a second because, well, I'm going to be writing on the screen, so I'll just be looking up to the air. But hopefully, you'll get this in time to help you prepare for class tomorrow. Okay. So let's read through this. I'm going to work through it essentially. I think it's the first or the second time I've seen this question total. So hopefully I won't lead you astray. So a medical researcher completed a study comparing an omega-3 fatty acid supplement to a placebo in the treatment of irritability in patients with a certain medical condition. 19 patients with a medical condition volunteered to participate in the study, and they did it this way. Okay. Each patient took a randomly assigned treatment, omega-3 or placebo. That was week one. They did not take either the omega-3 or the placebo during week two. This is necessary to reduce the possibility of carryover effects. Okay. And then each patient took the treatment that they did not take during week one. Okay, so a couple of things to be thinking about right away. This is a matched pairs design. Um, when I see this, I'm immediately thinking paired data. And so those are things where we want to recognize, hey, we can very easily and comfortably block on each individual patient, right? Each patient is receiving both treatments. So we're going to be able to compare the data directly. So I'm actually going to subtract from the beginning, right? Um, and I will say part of this is me just knowing, hey, it's an inference procedure question because we gave it to you on this time. But in general, even if it was just an experimental design, we should know this matched pairs design. All right, it's going to give us paired data for what we're about to do. All right, so each patient's irritability was given a score of 0 to 10, with 0 being no irritability, 10 representing the highest level of irritability. For each patient, the two irritability scores and the differences in their scores were recorded. Okay, so here's the results. Okay. And so notice this would be if you're doing a two sample test. Mhm. For a difference in means. Notice we already have a difference here. This is for a mean difference that we're going to do as a one sample test. So they're making you think through, okay, so which one do I want? Um, okay, interesting. They gave us the graphs. Now, some people may be looking at that wondering why. For me, knowing inference procedures, right? Sample size of 19. It's not large enough for to invoke the central limit theorem, and we don't know if the population was approximately normal or not. But both these samples are fairly symmetric without outliers, so we can proceed. All right, so here we go. Researcher claims that omega-3 supplement will decrease the mean irritability scores with the medical condition. Okay, so that's what we need to collect evidence for. We can't assume this to be true. So that's going to be my alternative hypothesis. Is there convincing statistical evidence? I see that language. I'm thinking hypothesis test. Remember, you can do a confidence interval here, but it's a hypothesis test. Is ideal significance level of that. All right. So choose. I've got a matched pairs design. So I'm going to do a one sample t test for a mean difference. And so my null hypothesis is that mu sub d is equal to 0. My alternative, so he claims the omega-3 supplement will decrease the mean irritability with the medical condition similar to the volunteers. Okay, because it's versus a placebo, right? Um, and so a lower score is better, right? Um, so placebo minus omega-3. So that means that the irritability score for placebo needs to be higher. The omega needs to be lower. And so if I take a higher minus lower, it needs to be greater than 0. Okay. So notice even me thinking through this, right? I had to think through, do I want the score to be higher or lower? And so I want omega-3 to have a lower irritability score, which the majority of this data does show that, right? Another thing is the mean of the difference is 1.789. I just know off of how things work, if I'm looking at like a 1.789, that's over here, we always want the tail, right? If I were to go to the left, less than, that wouldn't make a ton of sense. So those are things to think about to kind of game the system a little bit. Where mu sub d, I'm just going to pull this directly from the context, is the true mean difference um, in irritability scores for all patients with the medical condition similar to the volunteers in the study. And then obviously placebo minus omega-3 treatments. And then alpha equals 0.05. All right, there's my choose. Check. Um, patients were the patients were randomly assigned to the order of the treatment. So randomness is there. I don't have to worry about 10% because it was an experiment. Um, the box plot of differences. Notice I'm not looking at the individuals. I'm looking at the differences because that's my inference procedure. Is not is roughly symmetric without outliers. That's how I'll say it. Large slash normal. There's my check. Let's do my calculate. So we're doing a t is equal to a statistic minus a parameter divided by the standard error. X bar d minus mu sub d divided by standard deviation divided by the square root of n. Don't forget, you can always do a formula sheet. I just know these well enough because I've been doing it for years. But I just throw that in there. So 1.789. My hypothesized value was difference of 0. The standard deviation was 2.485 divided by the square root of 19. And this is where I'm going to jump to the calculator. So my degrees of freedom, don't forget then, would be 18. So let's see. Menu, stats, test. It's going to be a one sample t-test. I've got statistics. We said 0. 1.789. I hope I remember that right. And 2.485. Sample size of 19. We said mu is greater than. And so, man, that was way higher than I ever thought it was going to be. 3.138. 0.138, degrees of freedom of 18. So doop, doop. And it's only going to be that little tail, p-value to 0.0202, I think, right? 0.0028. All right, and now let's conclude. Since the p-value equal to 0.0028 is less than alpha equal to 0.05, we reject the null hypothesis. There is convincing evidence for their difference. Let's say the true difference in irritability scores. Irritability. I don't think I spelled that right. Oh well. They won't dock you on the AP exam. Scores, placebo minus omega 3 for all patients like those in the study. Study being greater than 0. I'm just going to add in IE omega 3 decreases irritability, because that's really what it's all about. I know I'm screwing that. Come on. Yep, I knew there was an A in there. Irritability. That's going to irritability. All right. And so, yeah, let's go check the answers really quickly. I know that in here, where did they go? All right, so 3 sections. Let's just get through. All right. True mean difference of irritability scores for all people with this medical condition. T-test for a mean difference. So paired T-test for population mean difference by name or by formula. Single mean states the correct equality greater than 0. Okay. Okay, so do you notice when we talk about context, you had to have true mean as normal. I had to talk about people with medical condition and talk about irritability scores. Got to talk about all those pieces of the context. There's a lot of caveats in this one. I'll send out the answer key. I'll give an answer key to y'all tomorrow. Do you notice they did allow a confidence interval approach? But notice you could not do a two sample and get full credit. Okay, so random assignment, sampling distribution, sample size is less than 30. The box plot shows an approximately symmetric distribution with no outliers. Degrees of freedom. Okay, that's all I've got so far. Yeah, check independence condition for random assignment. Indicates distribution of irritability scores. Got that. I do like that they actually say that you need the sampling distribution to be approximately normal. They don't usually require that detail, but I would definitely highly recommend it because that's what it's all about, is the sampling distribution to be approximately normal. Notice they say correct T statistic consistent with the name test, because if you did a different test, then you'd have a slightly different T. And then p-value consistent with the stated alternative. Again, if you messed up your alternative at the beginning. So I know a few of y'all have gotten the p-value to be backwards, but if it's consistent with what you said in the beginning and you use that incorrectly in the later parts, you can still get full credit for the later parts. So don't sweat that. Start with what you got. Um, there's that fun degrees of freedom formula I showed you. So they use it, but the calculator also just does it for you. Okay. And yeah, we reject the null hypothesis. There is convincing statistical evidence that the true mean difference, placebo minus omega 3, is greater than zero. They are helpful in reducing irritability. So we had to compare p-value to alpha and a correct decision about the null and or alternative, state a conclusion in context in terms of the alternative hypothesis using non-deterministic language. What that means is, and you have to be careful about this, you cannot say we have proven this. There is convincing evidence of this, right? So that's something to keep in mind. Do they say anything about that? There we go. There's evidence or there's not sufficient evidence. You cannot prove a null. Notice we do not accept the alternative. We do not prove the null. Um, there's no evidence for the alternative. There's not evidence for the alternative. There's definitely evidence, right? So keep that in mind of is there sufficient evidence? So that's something we have to be intentional about. All right, I'm going to be quicker on this next one because I want to go to bed. Not bed. I really have other stuff to do actually. But all right, let's look at number 4. Um, so one of the two fire stations in a certain town responds to calls in the northern half of the town, and the other fire station responds to calls in the southern half of the town. One of the town council members believes that two fire stations have different mean response times. Response time is measured by the difference between the time an emergency calls coming into the fire station and the time the first fire truck arrives at the scene of the fire. Data were collected to investigate whether the council member's belief is correct. Random sample of 50 calls from Northern and their mean response time. Random sample of 15. Okay. Construct and interpret a 95% confidence interval for the difference in mean. All right, I'm gonna have to go ahead and create a new page here. Okay. So keep in mind for all of y'all that keep struggling with this, if it says construct and interpret, they still want the 4C method of inference. So choose. I'm gonna do a 95% confidence interval. It's not how you spell confidence. Interval for a difference in population means. Notice I'm referring to population there. And so it's going to be mu sub n minus mu sub s is the true difference in mean response times for north versus south fire stations. Okay, got confidence level. I've got parameter. I think that's it. Maybe I'll remember something later that I'm forgetting. Check. We have a random sample from each and independent samples, right? We just collected the data afterwards. The selection did not affect one or the other, so there's my check. Um, I've got it's safe to assume 50 less than 10% of all calls. And then 50 is sufficiently large for CLT to believe sampling distribution approximately normal. All right, there's my check. Calculate. So statistic plus or minus critical value times standard error gives me x bar 1 minus n minus x bar south plus or minus t star times square root of Sn squared divided by Nn plus S squared south divided by N south. All right. Let's run this. Actually, let's just go put in some values. 4.3 and 5.3. Plus or minus. I want to leave that t alone for a second. 30.7 and 30.2. Okay. So I'm going to use my calculator to do the confidence interval, t interval. 4.3, 5.3, 3.7, 2, 50, 50. Confidence level is 95. Cooling, no. Okay. Go ahead and check and make sure I didn't screw that up at all. Okay, nope, looks good. All right, so my degrees of freedom is 96. All right, so let's do an inverse T. So inverse T. All right, so it's 95% to 0.975. If you're not sure about that, I'll show you why in a second. It's 96.0045 or so. Yep. All right, so 1.985. You'll notice it's really close to the 1.96, just a little bit wider. So for anyone who's like, why in the world should you 0.975? Remember, if it's a 95% confidence level, 0.95 is here, 0.025 is here, and 0.025 is here. So from here down is just 0.025. From here down is the 0.975. And so that allows me to get the positive version instead of the negative. That's all. That's the only difference. All right. And so the big priority though is here's my interval. Please remember that it's negative 2.373. So the really important part is being able to get the interval and interpret it. So even if you screw up on the writing out the formula, keep going. because your priority is to interpret that. Conclude with 95% confidence the true difference in mean, what was it? Response times. North minus south is captured by the interval from -2.373 to 0.3730 minutes. Okay. And then I think we have one more piece. Does the confidence interval support the council members' beliefs that they have different mean response times? This interval does not support the council members' belief because 0 is a plausible difference. All right. So let's go compare this answer to what we see online. Nope, not what I meant to do. So why am I struggling so hard? Right there. That's what I'm struggling. All right. Two sample T interval. The difference in population mean response times. I think that would be covered. Wow, that just looks terrible. Um, Conditions, independent random samples, large samples. To do. 95% confidence. The confidence interval for a difference in means, either by name or formula. Got that. So notice your formula can cover it a lot of times. I would recommend just doing both, let them inform each other. Sample size is large enough. Shows a correct confidence interval by displaying numbers in the formula or by writing the numerical interval. So yeah, so you'll see like lots and lots of options here, but just use your calculator to run it through. You didn't have to report the degrees of freedom, but you did need the T, so there's that. and 5 on minor. Okay. Let's indicate the interval is for a difference in mean response times, not a mean difference. Yeah, yeah, looks good to me. All right. Ooh, makes a correct conclusion supported by the fact that zero is contained in context. Ooh, did I use context? Yeah, see, I would not have given myself an E on that one. So, ladies and gents, learn from my mistake. Learn from, the thing I've been telling you to do all year. Make sure you put your context in there. I would say council members' belief is not enough context. All right, hope this helps you study for your DYU, and I'll see you tomorrow for it, and testing probably on Tuesday. Have a great one, guys, and I shall see you later.